Let's look at how to do multiplying and dividing with positive rational numbers. So rational numbers could be decimals, could be fractions, or could just be whole numbers. But we're going to avoid negatives for right now, so positive rationals. So that first one's a little bit too obvious, so we're going to skip that one. This one looks a lot more complicated, so let's try this one. So this one, we've got 43.4 divided by 6 1/5. So 6 1/5 is a mixed number, and 43.4 is a decimal. So for division especially, well, I guess you can go either way. You could either make them both into fractions. I would do improper fractions, or you could do long division if you make them both decimals. So I don't know. Let's show both. So let's make 43.4 into 43 4/10, which is the same thing as 43 2/5 if I wanted to simplify that fraction, not that it really needs to be. And then if I want to divide that by 6 1/5, I'm going to use rules about dividing fractions. But first I'm going to make this into an improper fraction because that will make this a whole lot easier. So 43 2/5 is actually equal to, we got to do a little bit of multiplication here. So 43 times 5 and then plus 2 all over 5. You multiply the denominator times the whole number, and that's how many wholes there are essentially, plus 2 over that many fifths, which I know sounds a little strange. If it's a little bit easier, if you say like 1 2/5, that would be 5/5 and 2/5, which is why it's 7/5. So I essentially multiply these two and then add those two in order to get that, the number of fifths needed to make it all over 5. All right, so 43 times 5, well, 40 times 5 would be 200, and then 3 times 5 would be 15. So this would be 215 plus 2 all over 5, which is 217 over 5. So that looks kind of, a little bit scary maybe, kind of a big number, but we'll figure it out. 6 1/5, let's do that one. So 6 1/5, same idea. 5 times 6 would be 30, plus 1 is 31/5. So now I'm dividing these two things. And you're like, oh, that makes it so much easier, right? That looks so easy. Not exactly, right? So that doesn't look so easy either. So division of fractions, what you can do is you can keep the first one, change to multiplication, and then flip the second one. And think about why that is. So say you wanted to do 10 divided by 2. That would be 5. Half of 10 is of course 5. But what I just said was dividing by 2 is the same thing as half, is making half, which is why, for example, this is the same thing as times the reciprocal, the flip of this fraction. Even though it wasn't a fraction, we can always put it over 1 and make it a fraction. So there's kind of a quick example of why it works. But of course, it is a rule that does work for fractions. Now, there's another shortcut here. You could do some canceling. I'm not going to show any canceling, just because, well, I guess there's a lot of different ways you could go. So because they have the same denominator, you could just do, actually divide across. That actually works pretty well when you've got the same denominator here, because you get 5 divided by 5, 217 divided by 31. So how many 31s go into 217, and then just do that long division. If I multiply across and multiply across, I'm going to be doing times 5 to both of them. So 217 times 5, 5 times 31. So you can actually just cancel those 5s out, and that's why it really is the same thing as 217 divided by 31. Which is why up here I'm essentially dividing across when you've got the 5 divided by 5 is 1, and then this would be 217 divided by 31 there. So it's all the same thing. So maybe that's too many different ways of doing it. But essentially all we need to do is divide 217 divided by 31. Long division. So I'm thinking about 21. I'm thinking about 30 or 3. 21, 3. I'm thinking it's probably 7. Because if you do 7 here, 31 times 7, 7 times 1 is 7, 7 times 3 is 21, boom, 217. So I kind of got lucky there just thinking about 3 and 21, how those work, and that is our answer. After all that, the answer is just 7, which makes sense because 43.4 divided by 6 1/5 if you think about 42 is 6 times 7, it should be close to 7. Let me go back and show the way with the decimals. That might be a little bit trickier actually now that I looked through these steps here. So 6 1/5 would be 6.2. So 43.4 divided by 6.2. So you would do long division like this. And then what you do with long division when there's decimals is you don't really want a decimal on the outside. You don't want this number to have a decimal. So what we can do is we can just slide everything over. This is the same answer as 434 divided by 62. So we're going to rewrite it as that. So 62 divided by 434. And the reason for that is if you think about what this means. So you can rewrite it as a fraction. And then you just do times 10 to both parts. That becomes this new division or new fraction, because every division problem is really just a fraction. All right, and now we got to think about, okay, 6 and 43. Again, we already know the answers, so it's kind of, it's kind of silly at this point. But we know that 6 times 7 is 42. So if we're looking at 43-ish and a little bit more than 6, I would guess 7. And then I would go off to the side here, and I would try and see if 62 times 7 got me close, or how close it got me, I should say. And then I would see, oh, look, it's the exact same thing. Now, we happen to not get a decimal in here, but you could have had something left over, and then you just put a decimal. You would keep going with the long division process until you didn't have anything else. But that one was a nice just 7. We got lucky with that one. All right, let's try another one. Here. This one is actually a little bit easier, which is nice. Multiplying with mixed numbers always looks really challenging. Like, oh my goodness, there's so many parts to this problem. How are we ever going to do that? Well, what you have to do is just make them both improper. So like we did before, so 2 times 5 is 10, plus 1 is 11 halves, times 5 times 9 is 45, plus 3 is 48 fifths. And then from there, we just multiply across the top and across the bottom. So 11 times 48. So that would be, of course, 48, and 48 with a 0. So this would be 528. And then this one down here, 2 times 5 is 10. So it's 528 divided by 10, which you could call 52.8. Or you could call that 52 and 8/10, or you can call it 52 and 4/5. So many, many, many different ways of doing it. Or not different ways of doing it, but there's not really a better way there. But you could, I guess you could actually, now that I say that, you could do decimals. Let's try decimals. So 5 1/2 is 5.5, because a half is 0.5. 9 3/5 is 9 6/10, which is 9.6. So now let's multiply those. So 5.5 times 9.6. You actually don't need to worry about lining up the decimals when you're multiplying. You do need to line up the decimals when you're adding and subtracting. So we're going to multiply these as if they're just no decimals at all. So 6 times 5 is 30. 6 times 5 again is 30, but now we have a 3, so 33. Let's add the placeholder. Do it again. 9 times 5 is 45. 9 times 5 is 45, plus 4 is 49. And let's just add these down. And this becomes 5,280. No, it looks like 5,280, but we have to go back to our decimals. Here we go back and we just count how many decimal places did we have. We have 1 here, we have 1 here, so we need 2 total. That moves our decimal in 2 times, and it becomes 52.8. So that's a different way of doing it, not using the mixed numbers. Everyone has their preference, but I think maybe fractions are a little bit faster. But again, you can do it either way.